Okay, so last time what we did was we recapped the GCSE trigonometry, where we looked at triangles, and so these were right angle triangles, where if you had an angle in that right angle triangle, then the opposite angle would be, sorry, the opposite side would be over here. And then adjacent to that red theta angle there, adjacent, that would be called A. And then your hypotenuse is the long side. And we can put that there. Okay. So, and what we saw was that using sine, cos, and tan, we could then find a ratio between those angles, which is always the same. So if you use sine theta, you can say that it's always, sine is always going to be, sine theta is always going to be some old hippie, or so, O over H, right? So sine theta equals O over H. So this is just a recap now, O over H. And then cos would be adjacent, and that would be A over H. And then tan would be tripping on acid, so that would be opposite over adjacent. So Sokoto was the way we could remember, or some old hippie caught another hippie tripping on acid. So you need to remember your sine, cos, and tan, and this allows you to find unknown angles and sides in a right angle triangle. So what I'm going to do now is we extend this theory to the Cartesian plane, in other words, to 360 degrees. So with a Cartesian plane, we must always remember that we start at 0 degrees over here and we work anti-clockwise. So it's not like bearing. So bearing, we start at north, right over here, north, and then we go clockwise, that becomes 90. So don't get confused with bearing and the Cartesian plane in trig or functions, where we actually go 0 and we go anti-clockwise. So this would then be 90 degrees. This would be 180 degrees. And this would be 270 degrees. And so when we come back here, this is actually technically could also be seen as 360 degrees. Remembering these angles is important later on. So we think of this angle as being an acute angle. So anything in this, well, let's first draw a triangle in here. So if I was to draw a triangle here, then what we have, well, a line up here from the center. And then if it was to come down perpendicularly like that, we actually have a right angle in our Cartesian plane, right angle triangle. So this is what we base most of our 360 degrees to 0 calculations, is based on this Cartesian plane and certain characteristics. So let's look first at this triangle. It's a right angle triangle because it comes down perpendicular. Now, if I was to say, well, what is the x coordinate? First, we'll do x coordinate over here. Well, that value would be x, right? And so we think of the x coordinate as being over here, and then the y coordinate will be y. Fairly simple, right? This would be the y, and this would be the x. And so the coordinates are x and y over here. That's the first thing we need to know about the actual triangle, in terms of, well, the first two things. And then the last thing about the triangle is that it has a hypotenuse right over here. So we can think of this length here along the y-axis as y. And then we can think of the adjacent as x. And we can think of it as having an angle over here. So what we notice is that our opposite angle is actually y. sorry, our opposite side is y, and our adjacent side is x. And our hypotenuse is h, sometimes called r, because it's radius as well. Like if we were to think of this being a circle, then this would be a radius here. So sometimes you'll also see r instead of h. Now, when we look at sine then, so we can think of sine as having a ratio of, so sine is opposite, right? So y. So the opposite is y. So when we're thinking of it in terms of a Cartesian plane, it simply changes to, instead of the opposite, it's just the opposite happens to be y. And then the hypotenuse, or the r, is, we could say r. It's also h. So I'm going to just say r. So it's the same thing, right? R and h, same thing. But I'm going to do it r because it is often shown like that. And then our a is our adjacent. Well, that's x. And so I've done it and I've color coded it so we can see that what we're thinking about is actually just the same thing as a normal triangle. It's simply just a triangle inside a Cartesian plane. Now, in this first quadrant, everything is kind of the same, except we're just using coordinates. And so then this one here, the last one, is y over x. Okay. So all we're doing now in this lesson is just looking at the Cartesian plane and how it works in terms of trig. No questions, just something to bear in mind. So watch it a couple of times, and it might make more sense if it doesn't make any sense now when we look at some actual examples. But for now, it's just, you just need to kind of understand that the Cartesian plane is used in trigonometry because it allows us to work with angles of greater than 90. Because now what I can do is I could do another perpendicular, another triangle on this side. And what I'm going to do is I'm going to try and make it sort of symmetrical to the other one so that we can see the differences. So this here then, do you notice that the x on this side is negative x and the y is still positive? And the radius or the hypotenuse must always be positive. That's something just to bear in mind. Our radius is always positive. We always think of it as positive. And so what we have then in this quadrant is sine theta happens to be, if we think of, remember, sine is y over r. So sine has to end up being y over r, which is y over r. And so we think of sine, notice that it's a positive over a positive. So sine theta remains positive in this quadrant. And that's why we kind of write an S here. And this will become clear at being a cast diagram. Now notice in the first quadrant, A, everything is positive. So we could think of this as being the first quadrant here. Now the second quadrant, what we notice is that we have y over r. And so sine is positive. Notice that x is negative. And so what we have is, and then y, as we said, is positive. And so we have our hypotenuse there, which we will, or the radius is r, it's always positive. And so notice that y is sine is the only thing that's positive in this quadrant. So I'm going to circle the things that are positive. And so sine we see as positive. And that's why we write this as an S there in that second quadrant. Now the third quadrant and the fourth quadrant, I'm going to go a bit quicker now. The fourth quadrant here, we do another angle here. Now notice that what we do in this, sorry, I just want to go back to the second quadrant. Now notice the size of this angle here. If this is theta, because it's the same size as the other one, I said it's symmetrical. Notice that this is a straight line here. And so this other angle is 180 minus theta. And so this is why we call this quadrant 180 minus theta. Now this is going to become clearer when we start doing some examples, why this 180 minus theta is such. And this one here is again theta, this angle here, but then the full angle all the way, if you were to go all the way around, let's try another color just so that we can, so if I was to go all the way around here, it's actually 180, this straight line here, that's 180 there, right? Plus this theta. So this one ends up being 180 plus theta. And I'm going to continue what the last one is just now, but so if I was to drop a line down here, remember these are right angles here, right angle here, right angle here. Now this, notice that everything is negative, right? Our x is negative x, and it's below the x-axis on here, so minus y is also. And so what ends up being the positive thing is, well, in the third quadrant we have, so this x, so the y is negative y, and the x is negative x. And the radius there is always positive. And so notice that sine and cos are negative over positive, both of them. So those are both negative. And the thing that ends up being positive is the tan, because it's negative over negative, which is positive. So tan happens to be the one. And so this is why we put a T here for a cast diagram. So it's just, I'm gonna do those in green actually, just to make it clear. So we have a cast, so that was A. And so that was the first one. The second quadrant was the S, where sine was positive. We noticed that everything was positive in this one, and that's why we're saying A for all. The third quadrant, the tan was positive. And then the final quadrant, it's called a cast diagram. So this is a C. Now we're going to see why it's C. Well, the fourth quadrant, we have, if we were to draw this triangle again here, too well. We have the radius is positive again. But now what's negative? The y is negative, negative y. And the cos, the x is positive. We see the x is positive. And so we have negative y here. The x is positive. And then the radius is positive. And so what ends up being positive here is the cos, right? The other two have negative in. And so that's why we have a cast diagram. Okay. And so this tells us what the sign is. So if a sign, if it's a 180 minus, whatever the sign is ends up being positive. The cos and the tan will be negative in that quadrant. This is going to make more sense later on, but I'm finally going to finish with the size of this angle here, right, is theta. And so if I was to go all the way around, I'm going to go around in a different color. Let's use purple. So if I started at my 0 degrees and went all the way around to here, this would be 360 minus this theta angle here. And so this is why this quadrant is called 360 minus theta. Now, this is sort of an explanation, but really, what are the main things you have to remember? Well, let's just summarize that in a much simpler one. The first thing is the cast diagram. Okay, and this tells you sine, cos, and tan, which ones are positive in which quadrant. All sine positive, tan positive, cos positive. Otherwise, it's negative. The other thing we need to know is that this is a theta acute angle. This is 180 minus theta in this quadrant. This is 180 plus theta in this quadrant. And this is 360 minus theta in this quadrant. So the thing that we're going to learn is this off by heart. The rest of the stuff that I went is just an understanding of how it becomes to be like that. But really, if you just remember this, I know a lot of people finish their AS levels without understanding how this works, but just memorizing this cast diagram. So that's what you need to learn. You need to learn this thing here. And so we're going to take this quadrant into the next lesson, and we're going to see, okay, why did we need to learn this? And we're going to see why. So I will see you then. So subscribe so that you get notified when that video comes on.